We started yesterday talking about logarithmic functions, and we're going to go back over again today and how to evaluate them and do some graphing. If b is positive and b does not equal 1, we can't have a base of 1, then x equals the log and base b of y if and only if b to the x equals y. I also think that starting off by saying it this way will get you used to it, since we started with logarithmic functions, that if y equals b to the x, then you can rewrite the logarithm in a logarithmic form as log and base b of y equals x. The same thing is the converse of what's said in the box. So the inverse of an exponential function, y equals b to the x, is the logarithmic function, x equals b to the y. But usually you write it as y equals the log and base b of x. I'm going to show you how to write inverses, etc. today. Write an exponential equation equivalent to the log and base 3 of 243 is 5. The answer would be write it as an exponential. 3 to the 5th is 243. Write a logarithmic equation equivalent to 6 to the negative 3 equals 1 over 216. That would be the logarithm in base 16 of 1 over 216 equals the exponent negative 3. All right, we're going to go forwards and backwards. You must memorize. This was that little shape thing that we showed yesterday, if it helped you to look at the shape. Now, I meant to get this all erased, so I've got to, excuse me, I was going to erase, and then some people came in and started asking me some questions, and my mind forgot a couple things. I'm just erasing a few things before we do it. Okay, I got to show you how to do this, not have you copy stuff. All right, so back to the first one. You need to memorize this. You have to be able to go forwards and backwards. This is the first one, right? Past what I already looked at. Oh, example 3 was evaluate the log and base 8 of 16. Now, we can do that using some information that we've already studied. If we rewrite this as an exponential equation, it would be 8 to what power is 16? Well, I'm going to put an x in for the box because I need to figure it out. And the way we figured it out was, and because I don't know a power of 8 that gives me 16. Well, actually I do, but I don't want to make you think about it right now. Okay, so what I'm going to say to you is, how could I solve this using the information that we've learned about bases and exponents? Previous section, we would say change 8 and 16 into a common base. What would the common base be? 2. So I can rewrite 8 as 2 to the 3rd. So that would be 2 to the 3rd to the x. My pen's stuck. Equals 2 to the 4th. 2 to the 4th is 16. You then can drop the bases and say 3x equals 4, so x would equal 4/3. Now, I have another way that I can explain how to figure this out. 8 to the x, 8 to some power, let's say you wanted to do it without this method, equals 16. Well, you got to still think about 2's, because you're going to think about how can I get, how would I get 2 out of an 8? You would have to take the cube root. Remember, roots are in the basement. And then if you wanted to get back to 16, you'd have to do 2 to the, so I would be thinking like this, it's sort of related to this. You could be thinking, well, the cube root of 8 is 2, and 2 to the 4th is 16. So the exponent here would need to be root 3 power 4, so 4/3. Okay, so you can try to figure them out that way as well. Right, but this was a way by changing the base. And it's essentially thinking like that is, anyway. All right, so let's go to, but they're not all going to be that hard. So if we were rewriting logarithmic equations, it's not asking us to evaluate, it's just asking us to go back and forth from the format that we need to memorize. If y equals b to the x, then the log and base b of y is x. I read that backwards. So this would be the base of x. The exponent is 5. The answer is 32. X to the 5th equals 32. Rewriting this one would be 5 to the exponent is 0, and the answer is 1. 5 to the 0 is 1. That is a true statement. I bet you could figure out what number 1's x value would be. 2. Okay. Number 3, we're just rewriting. 10 to the 1st is 10. Number 4, base of 10 to the negative 1 equals 0.1. Just to remind you, 0.1 is 1/10. So it does fit a little bit more. You can see it better by writing 1/10. Number 5, now we're going to write an exponential where base is 1/2. The exponent is negative 1. The answer is 2. And yes, 1/2 to the negative 1 would be the reciprocal of 1/2, which is 2. Now, what did the directions say? It said, oh, it didn't say anything yet. Okay. B, now I'm going to think, B to what power would give me a 1? 0. Okay, we just found a rule. Because anything, any base to the 0 is going to give you a 1. I'm going to show you another rule. B to what power is B? Yeah, so the answer to that is 1. So that's actually a rule of logarithms. So evaluating them next, we're going to rewrite exponentially and think 3 to what power is 81? And that's why I asked you to memorize a lot of the powers of some of the smaller x values or numbers, integers. The answer to that is 4. Now, let me explain something and please pay attention to what I'm going to say because I'm not going to accept, well, that's how you showed us to do it. All right, you need to not give me this with a 4 in it, okay? I don't want it. This is your thinking bubble. That's all you're doing is writing this to think about it. You don't even have to write this if you just think about it, okay? So I'm trying to teach it, so I'm showing you that's a thinking bubble. If you give me this and that's like your answer on the paper, you don't write this equals 4 or you don't write 4 in a blank for an answer, it's not going to be acceptable, okay? You have to give the answer that is an exponent. You don't just stick it in the exponent position, okay? So I want to be clear about that. This is what you think, the answer you write down. Okay, so the next one is log. And it's going to be like, how am I going to do that one? That says 0.04. 5 to what power is 0.04? Well, I'm thinking we better think about what 0.04 is as not a decimal, but a fraction. So if you remember, the first decimal place is tenths, the second is hundredths. So 0.04 can be written as 4 100ths. Okay, and so I'm going to be going 5 to what power? It's going to give me 4 100ths can be reduced to 1 over 25. Now I might be able to think in base 5. So what power, how do I get 5 to be 1/25th? You need to square it and do the reciprocal. So -2 is the answer to that logarithm. A logarithm equals an exponent. Okay, so 10, we got 1/2 to what power is going to give me an 8? Well, I know how to get, so here's what you want to think. 2 to the third is 8, right? You know that, hopefully, you've memorized it. So how do I make the half flip over? So I'd have to change the sign of the 3 to -3. So this would be -3. And the log in base 9, 9 to what power gives me a 3? Well, it's not a, what power? Well, maybe it's not a power. It's an exponent, but not a power. It's a root. Remember how the roots made the numbers smaller? So you can square root, cube root, etc. So how do I go from a 9 to a 3 by roots? Square root. What's the exponent that means square root? Not 2, but they're fractions. Remember, roots are in the basement. So this would be 1/2. half. Okay, 1/2 means the square root when it's an exponent. 1/3 is the cube root, 1/4 the fourth root, etc. Now, common logarithm is in base 10, and it will not generally say the base number will not necessarily be written there. If you see a log, then it's going to be base 10, unless you're in the woods. Okay, log of 5. What is the log of 5? Well, your calculator has this on it. If you went like this, 10 to what power will give me 5? Well, I don't know. The square, I know it's between 0 and 1, but I'm going to use the calculator because it's got base 10 on it. So you're going to hit log, LOG 5, enter. 0.6989, let's go 2 or 3 decimal places. If we go 2, that's going to be 0.70. Okay, log 21, press the buttons. This is the base that's on your calculator, 1.32 approximately. I don't know why my pen is sticking on me, 1.32. And it's better to go out further for accuracy, just so you know, when you plug that back in on an 10 to the 1.32, it's not going to come out to exactly 21 because we rounded. The natural logarithm, oops, I got a little erasing to do. I don't know what some of that was there. Okay, let me quick get rid of a few things here. Sorry. Should have pulled up my blank one. I don't know where it went. Okay, so the next common logarithm is base e. It will not, the log in base e of x is written ln x, where e is the base. So this would be e to the what power equals 0.1. Well, I don't know, and I'm lucky I have an ln on my calculator. So locate that. That's underneath the LOG, log button. I forgot what number we're doing. Are we doing ln with a 0.1? Thank you. And that's negative 2.303. I went 3 places. It's just more places is actually better when you're checking. ln of 2, if you didn't go 3 places, that's okay. Oops. I don't want that. Ooh, messing my thing up. ln of 2. 0.693. Now, to check that, you could type in your calculator second the ln button, which gives you e to the something, and then you could put 0.693 in the exponent position, hit enter, and see that you're getting really close to 2, but you're not exact because we rounded. All right. Next, it says science connection. The slope of a beach is related. Oh my gosh, I can't believe somebody figured this out. The slope of a beach is related to the average diameter in millimeters of the sand particles on the beach. Yeah. That's scientific. Okay, that's a lot of tiny measurements. Find the slope of the beach with an average diameter of sand particles that are 0.25 millimeters. Okay, so what does that stand for? D is the diameter, so we get a D of 0.25. We're just plugging in the formula, and we're going to use our calculators. So S, the slope, would be 0.149 plus, I'm not going to type the 0 again, 0.118 times the log of 0.25. So 0.149 plus, I got to look at my, maybe I better look at my notes so I don't have to flip back and forth there. Bless you. It was plus 0.118 log, it's actually times the log of 0.25. And the slope is not real big, 0.078-ish. Okay. About a 7.8% slope. Now we're going to use inverse properties. I'm actually going to help you develop and learn some properties. So we're going to rewrite this in exponential form and say 6 to what power is 6? 1. Okay, so here's how we can generalize this property. That gives us the log and base b of b will always be 1. Any base, it's got to go to the 1 to get that same number. All right, it has to be to the first power to get that same number. I'm going to give you a generalization after I show you how to figure this one out. This is an exponential equation. Ignore the fact that its exponent is a logarithm. So just for a moment, I'm going to say, well, I have an exponential. I'm going to rewrite it as a logarithm and see if I can figure this out. The log in base of 5 of something. Remember, I don't know what this is. Remember, this would equal something, right? We're trying to figure out the something, right? Would equal the exponent, which is log in base 5 of 13. So what has to go into the blank box in order to answer the question? 13. So the answer to number 18 is 13. Okay, I'm going to show you another one, and then I'm going to generalize. Well, I'll go ahead and generalize right now for this one. The log in base b of, sorry, I wrote the wrong thing down. I got thinking ahead and I wasn't thinking about what I was writing there. Some base, b to the log in the same base, b, of x, the answer will always be x. Okay, if this and this match, and you have an exponent of a logarithm and these match, the answer is going to be whatever's right there. So what should the answer be to 19, do you think? It should be 15. Okay, and let me show you why. It's an exponential right now. It's just in exponential form. So I'm going to write it in logarithmic form, which since it's an e base, I would do ln, which is base e, of what? Equals ln of 15. And any ln is understood to be base e. My pen is having a delayed reaction, pardon me. And what goes in this blank, that's not supposed to be a 0. I shouldn't have made it look like a 0. The blank would need to be filled in with 15. Okay, so e to the ln of 3, what's the answer? 3. And that again is because if you rewrote natural log in base e of something is the natural log of 3, which is base e, 3 would have to go in the blank. Okay, now this says 10 to the log of 2. I'm thinking the answer is 2. Okay, show you why it is. If you rewrote, again, this is a base of 10, log base 10 of something is equal to the exponent, the log of 2. What would have to go in that, and base 10 is what log is. You put 2 in that blank. All right, here we're going to have, oh, that we didn't write this one down yet. B to what power gives you a 1? Yeah, 0. All right, there's a rule for us right there. The log in base b of 1 is always 0. Log it in any base. Doesn't matter what the base is. So those are all logarithm rules. Using inverse properties, we figured them out. Okay, so now we're going to find this inverse. Remember inverse graphing? Inverses are reflections up over the line y equals x. You don't have to draw that if you don't want. Exponential functions do this stuff, remember? And logarithmic functions are reflections of them over that line, so they do that. All right, so all I'm doing is finding the inverse. Remember what the inverses do? They switch the domain and the range, and when we solve through them, we switch the x and the y. So you can either do that right away or you can do it later, up to you. If I switch x and y right now, which is what we used to solve our inverses, we would just trade them, and then we would exponentiate this, so meaning rewrite it in exponential form. The base of a natural log is an e, so x would be the exponent, and the answer would be y. So then you would turn that around to write your inverse, y equals e to the x. At least that's how I do it. Some people put the ln part first. All right, I look at this as a base of 3, and so let's say you didn't do that. 3 to the exponent y equals x. You can then do it this way, exponentiate first, and then rewrite it by trading x and y. So y would equal 3 to the x would be the inverse function. Okay, so it doesn't matter to me how you do it as long as you remember to switch your x and y at some point. Okay. I rewrote it with an exponent and then switched x and y. Okay, this one? If I switched x and y right in the beginning, and now I'm going to write it in exponential form. Base of 3, exponent x equals y, turn it around. Did you get that one? Then do it that way. So you guys, are we okay? Because I don't care which way you do it. I'm thinking that since before I taught you to switch x and y in the beginning, that I should have maybe done it that way. But I've seen it taught different ways, so I thought I'd say it 2 different ways. Okay? Yep. Base e. Natural log. Yep, that's we just log. If it doesn't have a number there, is 10. So if it just says log of x, it's base 10. If it says natural log of x, it's base e automatically. They'll never be that. They'll never have ln with an 8 for a base. You don't need to do that. We just use log. Okay, going from there. Ooh. So I guess that was stuff. So we're going to graph in a minute. Finding the inverse again. Okay, so let's say we all know how to exponentiate this or change it to an exponential equation, right? Base is 10. Exponent is y equals, and that answer here is x. Okay, now switch x and y. That's all I did before. So 10 to the x equals y, and then I turned it around. I think this one, probably better if we just go ahead and switch x and y right now. Okay. Switch x and y. We're going to need to exponentiate the basis e. E to the x equals y plus 1. Then we would subtract 1. E to the x minus 1 is y. And typically we rewrite as y equals e to the x minus 1. So you're doing something you never knew what the heck it meant before, and it's really not that bad, hopefully. I'm hoping. Right, I looked at this the first time on that pretest and went, oh my gosh, what are these things? Okay, so now we're going to graph. So we're going to treat this y equals log of x as the parent graph. Graphing logarithmic functions. The function y equals log base b of x, where b isn't 1, is called a logarithmic function. The graph of f of x equals the log of base b of x represents the parent graph of the logarithmic functions. Properties of the parent function are described in the following table. The function is continuous, that just means it has no holes, and 1-to-1. Okay, so it's a 1-to-1 function. Its inverse, therefore, is also a function. The domain is a set of all positive real numbers, so that would be from 0 to infinity. And the y-axis is an asymptote of the graph, which another way to put that is x equals 0 is the y-axis is as a vertical line. The range is a set of all real numbers, which would be negative infinity to infinity. If my pen would write. Oh. And the graph contains the point 1, 0. Whereas the old graph, or the exponential function graph, was its inverse, and it had a y-intercept of 0, 1. So the graphs of logarithmic functions can be transformed by changing the value of the constants a, h, and k. Now, a would stretch or compress the graph. The h shifts it horizontally, left to right. Then the stretch or compress is vertically, a vertical stretch or compress, because when you get to pre-calc, you will do some stretch or compresses with respect to the horizontal. Okay, the vertical asymptote is y-axis, or x equals 0. Now, that's as if it's not transformed. So what's going to happen on these is, you know how the exponentials, the k moved the asymptote? Well, these are inverses of that, so it's not going to be the k that moves the asymptote. Now it's going to be the h, right? So we're going to graph y equals log base 10 of x. But the thing I'm going to think about, and we'll rewrite, we'll do the rest of this in a minute, is writing it exponentially. If I write it exponentially, it would say 10 to the y equals x. So if I want to make a t-chart, I'm not using the grapher, guys. I'm trying to show you how to do this without. You can type this one in the grapher, but you can't type in other bases, which that's why people were confused with their, there were a few graphs you will probably want to ask me about from the last night's assignment. Okay, so let's put in some values. What do we want to put values in for, though? Yeah, maybe. Well, otherwise, you're going to have to put in powers of 10 in for x and figure out the exponent. So that's why I rewrote it this way, for you to see that you want to put in stuff for y. So if you put in -1 for y, you'd have 1/10 for x. If you put in 0 for y, you would have 1 for x. If you put in 1 for y, you'd have 10 to the first, which would be 10. All right, we got 3 points. Those are the ones I'm going to use. 1/10 is barely going past 0 to the -1. This thing is going to hug that y-axis right away. 1, 0 is the next one, and then 10, 1. So this thing is traveling along this y-axis and never crossing it, and then it's turning sharply just to hit that 10, 1. I didn't do a very good job. Get an arrow on that. So here's another reason why you don't really want to look at your grapher. If I go into y equals and I clear out what's there and I just type the log of x, and then you think you're going to get away with graphing this for me, you are sadly mistaken. If you just give me some little hook thing like that and don't show me that it runs down the y-axis and be able to tell me that that's an asymptote, or if you start showing me points on the y-axis, then you're going to get it marked wrong. Okay? The grapher cannot show those tight points. They're too tiny. Right? It can't. It just doesn't show them because it's hugging so close, but it is not crossing it. Okay, so you need to know that. You can't just rely on the graphing calculator. All right, so the x-intercept was 1, 0. This one didn't have a transformation, and that's why I wrote those up there. This one has no transformation because it's the parent. The domain was from 0 to infinity, and the range is negative infinity to infinity. It might be hard to tell that that's ever going to go up, 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 and away, but it does. Takes a long time, though, for it to get very high. All right, so let's compare the next graph to this one. I just forgot. I have to get this erased. All right, let me get the next 2 graphs or 3 graphs erased real quick so I can just explain them. Okay, so what I see here is an h value. Remember the format was y equals the log of x, oh, it was a times the log of x minus h plus k. All right, there's no a value, or the a value is 1, so it's not stretched or compressed. The h value is negative 1, which means it's shifted horizontally left 1. Now, the old asymptote was x equals 0. Well, it's going to move over to x equals negative 1 because we just shifted the asymptote to the left. You must show that dash, or you can use highlighter. Doesn't matter to me, but you need to show that line, else you will not be. You're going to get points up. Some of you did not show that line of the asymptote that was shifted on your quiz. If you crossed it or showed points on it, I took off something because some people acted like there were points on it. No points are actually on the asymptote. They're just really, really close. So there's no vertical shift at all. It was horizontally just left 1. So now the domain changed, though, because now it's from negative 1 to infinity, but you don't include the negative 1 asymptote. The range is still going to be negative infinity to infinity. Now, what happened to the points? Well, those key points that we graphed in the last one, like 1/10 negative 1, shifted left 1. The other point was 1, 0, and it shifted left 1. So now the vertical asymptote here is x equals negative 1, and the x-intercept moved to 0, 0. The point 10, 1 shifted left 1, and it becomes 9, 1. Not becomes, but the new point is there. So that's how you can just transform the graph by doing the shifts and get it graphed. Were there any other questions on there? Nope. Okay. Let's try another. This one has a k value. That is a k. So this is a vertical shift up 4. That did not affect the y and the asymptote. So if you wanted to use a highlighter, it's going to be x equals 0. Well, I constantly do want you to keep showing you know where the asymptotes are. So I'm going to say yes, because some people tend to just not do it then when it's transformed. Okay, so let's see. The point 1/10 negative 1 shifted up 4. 1, 2, 3, 4. The point 1, 0 shifted up 4. 1, 2, 3, 4. And the point 10, 1 shifted up 4. 1, 2, 3, 4. And then we just sketch. Oh, I'm not supposed to be crossing. There's another reason why highlighting the asymptote is helpful, because not everybody graphs perfectly, and I just made a mess of mine. Try again to hit that point. There we go. Domain is 0 to infinity, and the range is negative infinity to infinity. The vertical asymptote is the y-axis, or x equals 0. And the x-intercept, you might be saying, where is it? So I'm going to show you how you can get it. When you do an x-intercept, what are you putting in for, what value do you automatically know? The y value, which is 0. Okay, so let's put in 0 for y into that equation. 0 equals the log of x plus 4. Well, let's rewrite this exponentially. So base is 10, exponent is 0, and that will equal 10 to the 0 equals, what am I doing? Something's going wrong in my brain. I know what it is. What did I need to do before I could exponentiate it? Yep. I don't know what, that's why I didn't know what to do. Okay? Because I need to isolate the logarithm before I exponentiate it. So that was a good lesson. I don't know why I did that just now because I didn't do it second hour. But I would subtract 4. Okay, so now I can exponentiate because I have the logarithm isolated. So the base is 10. 10 to the negative 4 equals x. And that would be 1 over 10 to the 4th, which is 10,000. That's pretty darn tiny. Not like you can show the graph where that is or plot it very easily. All right. We have another one to graph? One more. Oh, double shift. Okay. This one is actually going horizontally right 2 and vertically up, oh, not up, down 3. And there isn't a stretch, so that's good. All right, so if I went right 2, I got to move my asymptote to 2, which means my domain is going to be 2 to infinity. My range is going to stay negative infinity, infinity. My vertical asymptote, we just said, is x equals 2. Okay, now I'm going to start transforming. Right 2 down to 3. So I'm going to think about the first point I plotted when I graphed the parent. It was at 1/10, negative 1. So I'm going to go right 2, 1, 2, and down 1, 2, 3. Bing. There it would be. The second point I graphed in the parent was 1, 0. So I'm going to move that right 2, down 1, 2, 3. And the third point I plotted on the parent graph was 10, 1. So I'm going to go right 2, down 1, 2, 3, and get right off my graph. And then I'm going to sketch the graph. Now, I don't see the x-intercept. I know you don't either. So we're going to figure it out. It's so tiny. It's almost nothing. Well, it is almost nothing. Let's see how little it is. You would be putting in 0 for y. So I'm actually show you how to solve for it. 0 equals the log of x minus 2 minus 3. The first step is to isolate the logarithm, so we would add 3. And then we would rewrite as an exponential. 10 to the 3rd equals x minus 2. So it'd be 10 to the 3rd plus 2 equals x. It's not, did I say so tiny? Or did I should have said so big. I don't know why I said tiny. It's just going to take forever to get to that x-axis. The x value is 10 to the 3rd plus 2. That's 1,002. Yes. So not thinking I'm going to graph that. It's 1,002 before it hits the x-axis. Not going up very fast. Hard to conceptualize that range being going up to infinity. Okay, let's just talk about this real quick. Well, what if I made you do this and you take a piece of paper? I wasn't going to, but we're like in halfway to the door and never getting out then. Okay, so what could you write that would be an equivalent pair of log and exponential statements? Just write, the easiest way to do it is write an exponential first. All right, so what if you did base? What would this equal? Okay, so how did you write a logarithm that's equal to that? Base is, of, is, yeah. Now this is what we've got to learn to do. Bang, bang, bang. Go from one to the other and from that one to this one. Okay? That's what you have to memorize and go forward with. All right. Your assignment is 13. It has the book page on it already printed out for you. All right. Now, tomorrow I have a short lesson, and then we'll be having a work day on Friday. So we're going to be time to ask questions, see what else you weren't able to do on the other worksheets, etc. So I will have time for questions coming up.